Good morning, children. We are back with the same chapter, electrochemistry. I would just like to revise the portion that we need to discuss today. The first part of the chapter we would like to discuss is oxidation. What is oxidation? Oxidation is a process where there is gain of electrons or loss of hydrogen, or there is loss of electrons from an atom, or increase in the oxidation number of that atom of that element. Okay, so if I want to summarize what is oxidation, I can say that oxidation means gain of oxygen. Oxidation means also loss of hydrogen. Oxidation means also loss of electrons from the atom of that element. Oxidation also means increasing in the oxidation number, right? Now, what is reduction? Reduction is a process where there is loss of electrons, where there is gain of hydrogen, where there is gain of electrons, or there is a decrease in the oxidation number. If I summarize what is oxidation, what is reduction, we can discuss it like this, that oxidation means gain of oxygen, loss of hydrogen, loss of electrons, and reduction is exactly the opposite of oxidation. Okay. Now see, both oxidation and reduction, they takes place simultaneously. That is, both the reactions takes place together, and it is together called as redox reaction. So always remember, if oxidation is taking place somewhere, reduction is also taking place in other part of the reaction. So just remember, oxidation reduction takes place simultaneously, and that's why it is called a redox reaction. That's why it is called as the redox reaction. So always remember, oxidation and reduction, they take place simultaneously, so it is called a redox reaction. After that, see, we have the next term, that is called reducing agent. Now the question comes, what is a reducing agent or what is a reductant? We know that these are substances that itself gets oxidized and helps in reduction. Reducing agent or reductant, these are the substances that itself gets oxidized and helps in reduction. Oxidizing agent or oxidant. So oxidizing agent or oxidant are, these are those chemical substances. These are those chemical substances that itself gets reduced and helps in oxidation. Okay, so they are called as reductant. So just remember, oxidant means that itself gets reduced, and reductant means that itself gets oxidized. So both of them are opposite of each other. As I have told you, oxidation is exactly the opposite of reduction. In the same way, oxidant is exactly the opposite of that of reductant. Oxidant is exactly the opposite that of reductant. Okay. Now we have a reaction over here. Check this reaction. We have metallic zinc that is made to react with copper plus 2. As we know that zinc is much higher up than copper in the electrochemical series, so zinc will get changed to zinc plus 2, copper plus 2 changes to copper. Okay, so as zinc from zero oxidation state, as you could see, zinc is having zero oxidation state, it changes to zinc plus 2. So here what is happening? Oxidation has taken place. On the other hand, copper plus 2 is changing to copper 0. What has taken place? The process of reduction has taken place. So I can say both oxidation and reduction has taken place simultaneously. Both oxidation and reduction has taken place simultaneously. So, or I can say that oxidation reduction are such reactions where both oxidation reduction is taking place simultaneously. So this type of reaction is called a redox reaction. This type of reaction is called a redox reaction. So have you understood this part of the chapter, children? I'm giving you 2 minutes time, copy it. After that, I will move to the next part of the chapter. I hope you are copying it, children. Next, we are moving to the next part of the chapter. See, the next part of the chapter you have is galvanic cell. What is a galvanic cell? So, galvanic cell is a device. First of all, a galvanic cell is a device. Now, the question comes, what is in that device? A galvanic cell is the device in which chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy, where chemical energy is converted into electrical energy, or I can say that it is the device in which chemical energy gets converted into electrical energy, is also called a voltaic cell. It has another name, it is also called electrochemical cell. So just remember, galvanic cell is called the electrochemical cell, galvanic cell is also called a voltaic cell. So a galvanic cell is called electrochemical cell. A galvanic cell is also called a voltaic cell. A galvanic cell is also called an electrochemical cell. So just remember, these are the major definitions of a galvanic cell. If in exam they ask you what is a electrical cell, what is a voltaic cell, I hope you can answer it. That is, a galvanic cell is called a voltaic cell. A galvanic cell is also called a electrochemical cell. I hope you have understood this part of the chapter, children. So if you want to write down the definition, please write it down. It is a device in which chemical energy, it is a device in which chemical energy is converted into electrical energy. That is, just remember that we have certain chemicals stored inside a cell. Now this energy that is stored inside the cell, that is being gradually converted into chemical energy, right? So the chemical energy converted to electrical energy. If it is a rechargeable battery, I can again change the electric energy into chemical energy. In this way, the whole cycle goes on. So I can say a electrochemical cell or a voltaic cell or a galvanic cell is a device in which there is the constant conversion. There is the constant conversion of a chemical energy into electrical energy. Okay, there is a continuous conversion of chemical energy into electrical energy. That is called as a galvanic cell, or that of a voltaic cell, or that of a electrochemical cell. Right? Next we have Ohm's law. Next, if you want to write down definition, I'm giving you a few seconds. Please write down definition of a galvanic cell. Please quickly write down definition of a galvanic cell or that of a voltaic cell. Okay, children, the next topic we have is Ohm's law. See, Ohm's law, to study Ohm's law, we should know a number of things. First of all, we should know potential difference, and the second thing we should know is the current. So when there is a potential difference, then only there is the flow of electric current. So I can say that Ohm's law states that potential difference across the conductor. Suppose I have a conductor that allows the electric current to pass through it, or I can say the potential difference across the conductor is directly proportional to the current flowing, is directly proportional to that of the current flowing, or V directly proportional to I, or V equals to Ri. V equals to Ri. So here I can state that Ohm's law states us two important things. One is that when electric current passes through a conductor, conductor is a substance that allows the passage of electric current through it. See, I can say copper wire is a conductor. Why copper wire is a conductor? Because it allows the passage of electric current. So when current flows through an electric conductor, the potential difference that is being developed, that is directly proportional to the applied current. So I can say that potential difference V is directly proportional to I, right? Potential difference V is directly proportional to I, or V equal to a constant R I. What is this constant? This constant R is called the resistance. The constant R is called the resistance, okay? So according to Ohm's law, what we know, that the potential difference across the conductor is directly proportional to the current flowing, or I can say V directly proportional to I, or V equals to a constant Ri. What is R here is the constant, and this constant is called resistance. This constant is called the resistance, okay? Now the next question comes, what is that resistance? So I'm repeating it once again. Ohm's law tells us that potential difference across a conductor is actually directly proportional to that of the applied current. So I can say V directly proportional to I. If I have to remove this proportionality sign, I put a constant, and this constant is called as resistance, and this constant over here is called as the resistance, okay? Now we have discussed what is the resistance. Now see, resistance is actually the intrinsic property of a substance. What is the meaning of intrinsic property? The meaning of intrinsic property is actually the property which is the constituent property of that substance, or it is a characteristic of that substance, okay? So I can say that resistance is the property of a substance by which it obstructs the flow of electric current. You should try to understand that when through a metallic conductor electric current is passing, it is not that the metallic conductor does not always allows current to pass. It might be obstructing its flow. It is exactly like comparing yourself going in an empty road. If you are going in an empty road in a bicycle, you can have the highest speed. But if there is a crowd, what will happen? Your speed will automatically decrease, because that road is not so empty for you to move. In the same way, whenever current is flowing through a metallic conductor, there are certain property of the conductor that actually stops the free flow of this current, or it obstructs the flow of this current, and this obstruction of the current is called the resistance, or that which stops the flow of the electric current is called the resistance of that conductor. So have you understood this part of the chapter? What is resistance? It is the property of a substance by which it obstructs the flow of electric current. It is the property of a substance by which it obstructs the flow of the electric current, that is called our resistance. So see, now what we know, the resistance R is directly proportional to the length of the conductor. If the conductor is large, obviously what will happen? There would be large amount of resistance. It is inversely proportional to the area of cross section. What is A? A is the area of cross section, that is larger the area of cross section, what will happen? More is the larger the area of, I should say, cross section, lesser is the resistance, because R is inversely proportional. If I combine these two equation, we have the first equation and the second equation, we combine it. So what we get? R directly proportional to L by A, or R equal to, here, in order to remove this proportionality sign, we actually have another constant. This constant is called as resistivity, or it has another name that is called specific resistance. It is called resistivity, or it has another name that is called specific resistance. So have you understood this part of the chapter, children? That is, whenever we apply a resistance, that is, I told you the resistance is the intrinsic property of a substance by virtue of which it obstructs the flow of the electrons. As it obstructs the flow of the electrons, what actually happens? Electric current cannot flow smoothly that it should have moved. So what it does, it actually stops the movement of electric current, and that is called the resistance. So I can say that R is directly proportional to L, R is inversely proportional to 1 by A, or R is directly proportional to L by A, or in order to remove this proportionality sign, we have another constant. That constant is called resistivity, or it is also called specific resistance. It is called resistivity or specific resistance. So I can say R directly proportional to L by A, or R equal to a constant, and this constant is called as resistivity or specific resistance. Okay, and what is the unit of resistance? Unit of resistance is ohm, OHM. The unit of resistance is ohm, that is OHM. So have you understood this part of the chapter? I am keeping it for some time for you to note it down. Please note it, then I would move to the next part of the chapter. I hope children you have copied it. Okay, now we are moving to the next part of the chapter, that is conductance. See, the next part of the chapter is conductance. Now the question comes, what is conductance? See, in conductance it tells you it is the reciprocal of resistance. See, whenever current is flowing, now what we have noticed, that because of the current flowing there is some resistance. Now what is conductance? It is the reciprocal of resistance. Conductance is represented by the symbol capital G. That is, it is the reciprocal of resistance offered by a conductor, and is the ease with which the electric current flows through a conductor. So what I told you, what I have told you, that conductance is such a, what I have told you, that resistance is such a substance, what I have told you, that resistance is such a substance which actually obstructs the flow. What is conductance? Conductance is actually the reciprocal of resistance. Conductance is actually the reciprocal of resistance. What does that mean? Conductance is actually the reciprocal of resistance. What does that mean? It is the reciprocal of resistance offered by a conductor, and is the ease with which the electric current flows through a conductor. And is the ease with which electric current flows through a conductor. The meaning implies that it is how easy electric current can pass through it. How easily electric current can pass through it, that is actually the conductance of that substance. So it is the reciprocal of resistance offered by a conductor, and is the ease with which the electric current flows through a conductor. Okay, how easily, how nicely it can flow, that is called as conductance. Or I can just write G equal to 1 by R. I have told you that conductance is the reciprocal of resistance, or I can write G equals to 1 by R. The SI unit is Simon. See, SI unit of conductance is Simon, and the symbol is S. Or I can say that 1 Simon equals to 1 ohm. 1 Simon is equals to 1 ohm inverse. I should write 1 ohm inverse, or I can write 1 Simon equals to ohm, right? Either I represent it in this way, or I represent in this way, right? So I have told you that conductance is the reciprocal of resistance, or I can say that conductance is the ease with which the current can flow. See, the obstruction is the resistance, but the ease with which the current can flow, that is called the conductance. Or I can say that G equals to 1 by R, or the SI unit of conductance G equals to Simon S, or it is represented that 1 Simon equals to 1 ohm inverse, or 1 by S equal to ohm, right? Okay, children, copy it. After that, we have the next part. The next part we have is conductivity. The next part we have is conductivity. When we were discussing resistance, I had told you that one is called resistivity. Exactly. While we are discussing conductance, we have another constant that is called as conductivity. So it is the reciprocal of resistivity. See, resistivity is represented by the symbol rho, and the reciprocal of 1 by rho is the conductivity. It is represented by a special alphabet that is called kappa. Although it looks like K, but the unit is called as kappa. So kappa equals to 1 by rho, or equal to 1 by R equal to L by A, or I can say 1 by R is G. So I can ultimately write that if L equals to 1, L equals to 1, and A equals to 1 centimeter square, the kappa equals to conductance. Okay, kappa equals to conductance. So conductivity is the reciprocal of resistivity. Conductivity is the reciprocal of resistivity, right? Conductivity is the reciprocal of resistivity, or I can write that kappa equals to 1 by rho equals to 1 by R into L by A, or G equals into 1 by A. If L equals to 1, A equals to 1 centimeter square, then kappa equals to G. What is kappa? Kappa stands for conductivity. So I'm giving you 1 minute time. Please copy it correctly. I hope, children, you have copied it. Okay. Now we are moving to the next part of the chapter. The next part of the chapter we have factors which affect electrolytic conductance and metallic conductance. So the next part of the chapter we have factors affecting metallic conductance. What are the factors on which metallic conductance depends? Now the question comes, what is metallic conductance? When current flows through a conductor, it might be a metal, right? It might be a copper wire, it might be a brass wire, it might be aluminum wire, okay, it might be a nichrome wire also. So when this current is flowing, that is called metallic conductance. What are the factors on which Metallic conductance depend. Metallic conductance means is with which the current should flow. It depends on nature of the metal. What is the nature of the metal? Next, the structure of the metal. Third is number of valence electrons or atoms. Number of valence electrons and atoms, and the next factor is temperature. So factors on which metallic conductance depends, they are nature of the metal, the structure of the metal, and number of the valence electrons or the atoms that the metal possesses, and also another factor is temperature. Okay, so I can say the factors on which metallic conductance depends is the nature of the metal. As you could see, it depends on the nature of the metal. It depends on the nature of the metal. It depends on the structure of the metal. It depends on number of valence electrons. It depends on temperature. Okay. Now the next thing, we have factors on which electrolytic conductance depends. See, electrolytic conductance depends on various factors. What are those factors? The factors are nature of the electrolyte or interionic attraction, solvation of ions, the nature of solvent and its viscosity, and last one is the temperature. Last one is the temperature. So just remember nature of the electrolyte. If the electrolyte is a strong electrolyte, obviously electrolytic conductance would be much more. That is the first point. Next is solvation of ions. How easily the ions get solvated by the solvent molecule, that is the solvation of the ions. Next is the nature of the solvent and its viscosity. What is the nature of the solvent and how does the viscosity changes, and next factor is the temperature. Next factor we have is the temperature. I hope children you are copying it. We are having is the temperature and how the temperature varies. Okay, these are the factors on which electrolytic conductance depends. I'm giving you some time, please copy it. নিচের ঘরটা না মুছতে হবে না। I hope children you have copied it. After that we are moving to the next part of the chapter, that is the difference between metallic conductance and that of electrolytic conductance. See, metallic conductance means when current passes through a metallic band. Electrolytic conductance means when current passes through an electrolyte. So when current passes through a metallic conductor, what we have there that is the movement of electrons. We have the movement of electrons, here we have movement of ions. So have you understood the first difference? The first difference is the movement of electrons, and in electrolytic conductance there is the movement of ions. Second difference, here it involves the transfer of electrons. Here matter moves in the form of ions. Here what we see, that matter actually moves in the form of ions. So there it involves the transfer of the electrons, and here it involves the movement of matter in the form of ions. Now the next one we have decreases. Metallic conductance decreases with the increase in temperature. Here electrolytic conductance increases with the increase in temperature. Increases with the increase in temperatures. Here it decreases with the increase in temperature. Here it increases with the increase in temperature. These are the two basic differences I can say about metallic conductance and that of electrolytic conductance. Basic difference between metallic conductance and that of electrolytic conductance. So have you understood this one? The basic difference between metallic conductance and that of electrolytic conductance. Okay. So I'm just summarizing it once again. The basic difference between metallic conductance and electrolytic conductance is that metallic conductance involves movement of electrons. Here it involves movement of ions. In case of metallic conductance, it involves the transfer of electrons. Here it involves that matter moves in the form of ions. Okay. The next part is that here with the decrease in temperature decreases with the increase in temperature. In case of electrolytic conductance, it increases with the if the temperature rises, what will happen? Electrolytic conductance will also increase. That is one major difference between electrolytic conductance and that of metallic conductance. Okay, children. Now we have the next topic, that is molar conductivity. That is molar conductivity. Now what is called molar conductivity? What is called molar conductivity? It is defined as the conducting power. It is defined as the conducting power of all the ions produced by dissolving 1 gram mole of an electrolyte placed between two large electrodes at 1 centimeter apart. Imagine that we have a galvanic cell, electrochemical cell, in which there are two electrodes. Obviously, one is the cathode, the negative one, and the other is anode, the positive one. In between these two, there is a difference of 1 centimeter, right? In between these two, there is a difference of 1 centimeter. Now when we have put an electrolyte, obviously the electrolyte is the ionic one. Now when the ionic electrolyte is put, then what will happen? They will start dissociating into positive ions and negative ions. Once they start dissociating into positive ions and negative ions, what will happen? Positive ions will migrate to that of the cathode and negative ions will migrate to that of the anode. Now, when they start migrating, in that case, what will happen? Cation would be discharged at the cathode, anion will discharge at the anode. Now, what is the molar conductivity? It is the conducting power of all the ions produced. That means all the cations and the anions that are produced in the solution. So, I can write molar conductivity equal to kappa into V, or that equal to kappa into 1000 by C, or unit is, what is the unit of molar conductivity? See this equation. Here we have molar conductivity equal to kappa into V, and V what we know 1000 by C, or unit equals to ohm to the power minus 1 into centimeter square per mole. Per ohm centimeter square per mole, or we can write S centimeter square per mole. Okay, this is the unit of molar conductivity. Okay, children, before we end in today's class, I would like to summarize what we discussed today. We had started the chapter with oxidation reduction. There I discussed with you what was oxidation, what was reduction. Then we have discussed about redox reaction. Then we have also discussed about oxidizing agent and reducing agent. Okay. After that next part of the chapter, we have discussed about Ohm's law. Under Ohm's law, I had discussed with you what is resistance, what is conductance. We have discussed about conductivity. We have discussed about resistivity. Okay, all these things we have discussed. Then we have discussed about factors affecting metallic conductivity and also the factors affecting electrolytic conductance, right? Then we have discussed the basic difference between metallic and electrolytic conductance. What is molar conductivity? All these points we have discussed. Okay. Okay, children, that was all for the day. If you have any query, you can call me at my number, okay? Or you can ask me in the next class. Till then, goodbye.